So for question 3.4, what you need to use is the z-score. All right, and so what we want to find is how many. What we're getting at here is when a thing is more plus or minus 2 standard deviations away from the mean, it's considered abnormal. And in fact, one thing I can just go ahead and tell you about myself is that I'm 6'8", which is a little bit over 2 meters tall, for those that are more familiar with meters. And so I'm one of these people that is an outlier. I have unusual height because there's so few people. The further and further you can get away from the average heights for a man, let's say, I don't know what that is, maybe 5'9" or 5'10", maybe is the average height for a male. The further you get away, either on the small side or the tall side, the more and more rare it is. All right, so that's what they're getting at here, is the further you get away from this mean of 1.244 for the Richter scale, the more rare that kind of an earthquake is. And so it can go either way. Although technically nobody's going to really care about earthquakes being too small, but we're going to do that anyway. So in section 3.4 you should have gotten that little text there. Alright, so if we take 1.244 and we're going to subtract 2 times 0.595. Alright, that's how we're going to find what they're calling the lower bound here, this lower bound. So we subtract 2 times the standard deviation. Now you have to be careful on this one, because if you punch this in your calculator as 1.244 minus 2 times 0.595, just like that, in that order, what your calculator generally does, or some calculators, not all of them, the graphing calculator should get this right, but anyone where you punch it in one step at a time, it's going to take 1.244 minus 2 and get negative 0.756 or something like that, and then you're going to multiply that by 0.595. Right, and that's going to be the wrong thing. Alright, what you need to do is make sure that if your calculator works this way, make sure you do 2 times 0.595 first, and you should get that's 1.19, I believe. I'll confirm it here in a second. Alright, so let me pull up my calculator and I'll check and see what this is. And so when I did this, I got 1.244, and it was in fact minus 1.19, and you get what I have on the calculator, 0.054. Alright, so let's put that in, and now let's see. I think this is a 2-part question. Alright, so I'll enter that and then we'll come back. Alright, so now for the upper bound, the higher bounders, as it said here, we'll use the same thing, but now we already know it's 1.19, so we'll do 1.244 plus 1.19. Alright, so I'll just go ahead and get the calculator here and do 1.244 plus 1.19, 2.434, and that should be the second part of this answer here. And so just to clarify again, where all this comes from is there's a formula we're going to use extensively, especially as we get into chapter 3, I believe it is, where we find the z-score is x minus mu divided by sigma, where this is the mean, this will be the standard deviation, this will be some value that maybe we want to test, and this is what we call the z-score. That's why it has the letter z there. We call it the z-score. So we can take this top part of the calculation, basically figures out how far you are away from the mean. Right? So find out how far you are, and then divide by the standard deviation to figure out how many standard deviations that is away from the mean. And the z-score is essentially how many standard deviations away from the mean you are. And so again, that's not something you're going to need to know right now, but we're heading to that direction. Alright, so anything that has a z-score of 2 or higher, or negative 2 or lower, represents something that's very unusual. Alright? Hopefully this helps.